Welcome. Now we are going to deal with an important solid aspect property, that is a permeability. Before I start with the permeability, I want to be clear to you that what the permeability means. Permeability, it is the property of a solid medium which allows the passage of water into it or a seepage of water. This is the permeability. Okay. Then, if the water is flowing through a soil medium, the flow of water determines the permeability. Then the soil, the type of soil determines. First, I deal with the type of soil. Based on permeability, I may divide it as permeable one and impermeable one. The permeable soil is one in which the water passes through the interconnecting voids, and the impermeable soils which the interconnecting voids are nil or lesser in number, which do not permit the water as a permeable one. For example, the permeable soils, gravels, or maybe a good example of a permeable soil. But in an impermeable soil, the best example may be a stiff clay, which do not permit water, or when compared to a gravel, the stiff clay will not permit that amount of water. Next, depending upon the water which flows into the soil, I may classify the water as laminar flow and turbulent flow. The laminar flow of water into the soil is similar when you drive a road on a perfectly runway, or when you drive cars in a race. You will follow a definite path. Similarly, the water follows a definite path in laminar one, and in a turbulent one, the water follows a zigzag curved path. Practically, all the soil are laminar. Okay. Next, why we have to learn the permeability? Permeability should be learned in deal with our civil engineering aspect before, because permeability is a property which affects or which has a direct impact on the settlement of a building structure. While you consider some hydraulic structures, the piping effects are basically due to this permeability. Then, while you can deal with some slope stability aspects, permeability provides a major important factor. So, these are the things in which the permeability deals with. So, there arises a need. So, why you have to deal with permeability. Next, before going into the permeability, we have to know what is the quantity of water which passes through it through a cross-section area. So, I am going to deal with Darcy's law. The Darcy's law of permeability. The Darcy's law of permeability gives a specific explanation on the quantity of water which flows through the soil and the time which taken, and the velocity of the water which flows into the soil. So, before going into the Darcy's law, I have to provide you with the assumptions. Every law has its own assumptions. Okay. The Darcy's law, the main assumption of Darcy's law is my soil mass is perfectly saturated. I am taking a soil mass, and the soil mass is perfectly saturated, and the flow inside the soil mass is constant and steady, similar to a laminar flow. My soil mass has a constant steady flow of water or seepage of water. Then the water flows throughout the cross-section area of the soil. I am not considering a particular area. The water flows throughout the cross-section area of the soil considered. And I am doing a test at a room temperature at 27 degrees Celsius. These are some basic assumptions made in the Darcy's law. Now, I just exhibit the Darcy's law. I'm just taking a container. If you need in the 3D, I'm important to keep on. I'm taking a container and this is another container. And this is my soil mass considered. The initial container has a height of, may I take it as a h1 height, okay, and my second container has a height h2 such that h2 is lesser than h1 and the difference in height between h1 and h2 is given by h1 minus h2, which is represented as del h. Okay. Then I am considering a soil sample of length L and a uniform cross section area. So I am representing, this is the breadth and this is the length. Let A be the cross section. As per Darcy's law, the discharge per unit time is directly proportional to the hydraulic gradient. This is the first one in the Darcy's law. Then I have to remove this limit of proportionality. So I am just introducing some constants. Q is equal to K I A, where I is the hydraulic gradient, Q is the discharge by unit time, and K is the coefficient of permeability, and A is the uniform cross section area. Therefore, I have to determine my I. Next, before going to this, let it be equation 1. Let me consider with another equation. The hydraulic gradient I, which is nothing but h1 minus h2 divided by the length L, which is the h1 minus h2 is the vertical one and L is the horizontal one. This gives my the hydraulic gradient of this flow. Therefore, from equation 1 and 2, I can write my discharge per unit time as, I am considering the 1 and 2. I am substituting equation 2 in 1, K h1 minus h2 divided by L into K. This is my final equation. If my K value is equal to 1, it can be known as simple permeability. Then, if my K value is greater than or equal to 1, it sounds for a gravel. Permeability in a gravel. As I mentioned before, the interconnecting voids are more in a gravel, so my K value will be greater than or equal to 1. My K value will be the order of 10 power minus 2 for sand, and my K value will be in the order of 10 power minus 4 for silt, and the K value will be in the order of 10 power minus 6 for clay. The clay may have a lesser K values. This is the principle behind the Darcy's law, and this is the permeability. If I want to calculate the seepage velocity, I can write it as Vs is equal to Kp into I, where Kp is the coefficient of percolation. I may write it as Vs by V is equal to kT by K, which will be given as 1 by amp. Thank you.